The radar case, in addition to the playful blinking LEDs, features data cards that allow you to display information on the screen. The first data card displays a selection of the club members of the Star Wars Fans Hannover, the Northern Outpost EV. The case was developed specifically for this club. The second data card contains blueprints of Imperial ships. The blueprints are displayed one after the other, just like with the club members. The final data card reveals the top-secret plans of the Death Star and how it can be destroyed. For those who want to learn more, watch the movie Rogue One. The lid of the case features a radar display and a playful touch with an animation. Now that you know what the case is capable of, let's move on to its interior. Don't be alarmed. There are a lot of cables inside, so it looks a bit messy. Here, you can clearly see the two connectors for the radar and the power supply. The small circuit board is a voltage converter from 12 volts to 5 volts. Here you can see the electronic heart of the case. It includes two ESP32 microcontrollers and one ESP32S3. The S3 was chosen because all the media data needs to be stored on the ESP, and the S3 comes with 16 megabytes of memory. One ESP32 is dedicated solely to controlling the LEDs, while the second ESP32 handles reading the data cards via NFC. Communication between the ESPs is achieved using ESP Now. The PCBs used here are custom-made but can be purchased in a similar form commercially. Let's now take a closer look at the individual components used in this build. This is the radar unit. It includes a servo motor that moves an HCSR-04 ultrasonic distance sensor back and forth. The HCSR-04 can detect obstacles within a range of 4 to 5 meters, and these measurements are displayed on the screen. The housing was 3D printed and downloaded from thinkverse.com. However, this unit is currently just a prototype. In the future, a larger antenna combined with the ultrasonic sensor is planned to be used. The next component we'll look at is the data cards. While the name suggests otherwise, no actual data is stored on these cards. They consist of two acrylic elements with an NFC tag placed in between. The NFC tags allow the electronics to identify which card has been inserted and determine which media to play on the display. Currently, we're using 3 data cards, but technically, more can be added. The only limitation is the storage capacity of the ESP32S3. These data cards are inspired by the Star Wars universe and were designed by Robert Biscup specifically for the Star Wars Fans Hannover Club. The next component we'll look at is the ESP32. We use 2 different models in this project: the older ESP32 DevKit V4 and the newer ESP32S3. Admittedly, we've been a bit extravagant with the use of ESP32s in this project. Some tasks could have been consolidated, which might have saved the need for 2 older ESP32s. The PCBs shown here are custom-made, but could also be purchased in a similar form commercially. Now let's move on to the displays. First, we'll take a look at the GA9A01 LCD. What's special about this display is that it's round and has a resolution of 240 by 240 pixels, which is impressive for its size. The GA9A01 is driven via the SPI bus. One important thing to note is that the content displayed should also be round to match the shape of the screen. The next display is used twice in the case, once for the radar itself and once for media playback linked to the data cards. This display is also controlled via the SPI bus and has a resolution of 480 by 320 pixels. It is available in 2 versions, one with touch functionality and one without. We are using the non-touch version. Finally, we come to the last display, the 7-segment display, commonly seen in devices like alarm clocks. These displays are available in various colors. Controlling them can be somewhat tricky at times. Now let's talk about the HCSR-04, the ultrasonic sensor used for the radar display. This sensor measures the distance to the nearest obstacle using ultrasonic waves. From this data, a radar-like image can be generated, even though it's not a true radar system. For the LEDs, we used pre-assembled modules. These LEDs can be powered with a voltage range of 3 volts to 6 volts, eliminating the need for a separate resistor or housing since they come as a complete package. Those were the most important components we've used in this project. In the next video, we'll cover the wiring, the case, and the inlays. Of course, we'll also make the individual parts available as STL files. In the final video of this series, we'll dive into the code, which we'll be releasing as open source. Please support us by liking the video and subscribing to our channel or page. Thank you for your interest in watching our videos. If you have any questions, feel free to leave them in the comments.